Today we're going to be proving geometric relationships. So the whole idea of a proof is that we take something that we notice about some geometric figures and we prove it is true for every case. Okay, by proving it's true for every case by using a very methodical, logical, step-by-step process, then we can start to use these properties or these theorems that we've proven and never have to go back and recalculate and refigure things out, okay? Because we'll have a theorem that says something like all right angles are congruent, okay? We don't have to go through all the legwork of showing that every single time. Does that make sense? Okay, so a theorem is something that it's based on a logical argument, and it's something that you have to prove. Postulate is something that we accept as a truth and don't have to prove, but a theorem is something that we have to prove, and once we've proven it, we can use it to simplify our lives and make things easier. Okay? All right, so first example. We're giving you a different view of a proof. So this is our two-column proof that we're used to, that we've been working with for a few days now. And this is something called the flowchart proof. And I want you to see how these two work together, or how they are similar. Okay? So in a flowchart proof, we start with something and we have a blank beneath it. And then we show how that thing and another thing branch together. These two things make this happen. This one moves to this, and then we bring on this and you know, and so forth. Okay? So we want to see how these things kind of come together. The reason we don't use flowchart proofs a whole lot, although I think they're very visual and they make a lot of sense, is that it's hard to decide where to put your boxes and make everything flow nicely. So if you have, you know, a computer program and you can be moving these boxes around, they fit nicely on your paper. But it doesn't always plot out well on just a plain old sheet of paper when you're writing. Okay, so let's see how this works. We are given the measure of angle 1 is equal to the measure of angle 3. So they nicely gave us this little mark to show that each of those angles are congruent. And why can we say the measure of angle 1 is equal to the measure of angle 3? It's given. Okay. Now, the next thing that they decided to write down for a statement was that the measure of angle EBA is equal to the measure of 2 plus the measure of 3. E to B to A, that big angle, is equal to the sum of the smaller ones, 2 and 3. Okay? Why can we say that? What did we do in our homework the other day? First example, number 17 that we worked out today. Yeah, angle addition. Add two smaller angles up and you get the third, provided that that ray is inside. Okay? Now, they took these two statements and merged them together to get the measure of EBA is equal to the measure of 2 plus the measure of 1. Why did it change from 3 to 1? What did they do? Substitution. Okay. Then next, they said that the measure of angle EBA is equal to 1 plus 2. Okay, this was still here, but instead of 2 we have 1, and instead of 1 we have 2. What says that we can change the order of an addition problem? Kind of like reflexive, because it's similar to changing the, reflexive is always you're equal to yourself, right? So that equal sign is like a mirror. Transitive means that we're doing the zigzag and removing the redundancy, right? So this one's one that we don't have on our sheet. I'm glad you were getting it out though. But we did see it one other time in our, I believe it was in an example. What says that you can change the order of an addition problem? Anybody remember commutative property of addition? Perhaps that should be in our notes. Okay. When I think of commutative, I think of O like an order. O is similar to what you would write for commutative. It says you can change the order of an addition problem. All right. Then they said the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle CBD. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle CBD. How can we say that? Angle addition again, exactly. Okay. So the measure of angle EBA is 1 plus 2. The measure of 1 plus 2 is the measure of CBD. How can we use these two statements to get EBA equals CBD? I would take substitution as an answer, but there's a better one. Because we're substituting equal things, right? But do you see that this is kind of that transitive? Good. We are getting rid of the redundancy and just going from first to last, right? So this would be better as transitive. Okay, follows that pattern. So what do you think of a flowchart proof? Not crazy about it? They're not easy to plot out. If I'm doing it on my computer, great, because I can move boxes around and change my arrows. I think it logically helps you follow to see, okay, these two things together helped us get this, and these two things together came to become this, right? But you can do that in a two-column proof as well. Okay, so let's write this as a two-column to see how it would work. All right, always first step is our given. If I write 3 correctly. And then what happened next? We used an angle addition property, right? We said measure of angle EBA is the measure of angle 2 and the measure of angle 3. Okay. Now, the next thing we said was the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. And that is by the first two, and you could say 1 and 2, and substitution. I use those two statements along with substitution to do that. And then the next statement would have been EBA is 1 plus 2. By changing the order, so commutative property. We use statement 3 and commutative. And then we had to get a measure of angle 1 and the measure of angle 2 to add up to the measure of angle CBD. Angle addition again. And finally, now that we have them in order, notice that these guys are on this diagonal, so it's easier to see that these two should be equal to each other. So measure of angle EBA equals the measure of angle CBD by transitive. We remove the redundancy. Okay? That's a flowchart proof. Okay, you'll see a couple of them, but we won't spend a lot of time with them. We just want to show you an alternate way of proving things. Okay, but most of our time will be spent in flowchart land, or sorry, in two-column land. Okay, so you spent some time writing down the theorems for this section. All right angles are congruent. If an angle, two angles are, or congruent angles are two angles are congruent to the same, are supplementary to the same angle, or congruent angles, and they're congruent. Two angles are complementary to the same angle or congruent angles, then they're going to be congruent. Linear pair postulate, what happens with a linear pair? Someone read it real quick. What was a linear pair postulate? I know it's Monday, you guys are tired. Linear pair postulate said what? They're supplementary. If they form a linear pair, then they're supplementary. Okay? And then the vertical angles is that if two angles are vertical from each other, then they're going to be congruent as well. Okay? All right. So I don't think there were any words there that we didn't know. So we kind of rushed through those, but those are things to pay attention to because we'll be using those. And we don't have to write down the theorem number. We just want to say all right angles are congruent, or right angle congruence theorem. I'll take either way. All right, so in this diagram, and use the diagram and the given angle measure to find the three other angle measures. Okay, so our textbook company says your book is pretty heavy as it is. So a lot of times we're going to give you a figure like this, and then in the directions we'll say, guess what? Measure of angle 3 is 128. Find the rest. Okay, then they'll give you another problem. They'll say the measure of angle 1 is 64 degrees. Find the rest. So they're not always going to put the values inside of there. So it's a good idea to have post-its because you can put them on there and then start writing up your post-its. Trace it and write up on your post-its instead of in your book. Okay? But they like to simplify things by using one diagram for many problems. And it saves space and therefore less pages and less heavy in your backpack. All right, so when you see something like this, either sketch it out on your paper or use a post-it and say the measure of angle 3 is 128. Put the 128 in your diagram. You'll be much more successful if you write that there because it will help you see those relationships. Okay? So, which angle do you want to find first? Page. Angle 1. Okay. So, angle 1 is related to angle 3 in what way? There's angle 3. Here's angle 1. They're vertical angles. They're formed by two pairs of opposite rays, right? And they only share a vertex. So what do we know about vertical angles? They're congruent. So good. 128 then for angle 1. Everyone see why and understand? Okay. So which one do we want to pick next, Logan? You want to find 2 or 4 next? Okay, angle 2. How is angle 2 related to angle 1? Good. They're going to add up to 180 because they are a linear pair. Good. They're supplementary. All right. So we're going to take 180 and subtract 128. And what do we get? 52. So if angle 2 is 52, what do you think angle 4 is? 52. Not too bad, right? That's how easy your problems are going to be today. Okay? As long as you recognize those relationships. You know what vertical angles are, you know what linear pairs are, you remember that, you're in good shape. Okay? Next example. Now we want to find the value of x. So what do you think we should do, Jacob? Why? Does it look like a good thing to do? You are exactly right, but why do we want to say that? What kind of angles are those? Vertical angles, right? Does everyone see that they only share a vertex? They're made by two pairs of opposite rays or two intersecting lines. They only share a vertex. They have to be equal. Okay, so that's going to be your problem, is to figure out how are these related, and then, and then set up the proper equation. Okay, so here we go. If I have 4x minus 3 equals 101, what am I going to do, Zach H? Add 3 to both sides. And the next step is going to be what, Erica? And so we divide by 4. Hopefully we get a nice, neat number, but sometimes we don't. And I see that will be 26. And they only said find the value of x because we already know what that angle has to be, right? If we plugged it back in, 4 times 26 minus 3 had better get us 101. But it's a good check. Make sense? What questions do you have on this slide? All right, next one. Now they want us to make a paragraph proof. Okay, paragraph proof. So, what do you think of when you think of a paragraph? English class, right? Or anytime that you have to write in writing, right? So they want us to put this in words, not 2 columns, not statements and reasons, but they want us to actually use our writing skills and throw the math in there. All right, so we are given angle 1 is congruent to angle 4. Always, 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 always. Mark up your drawing. It will help you. So 1 congruent to 4. Put an arc here and an arc here. And then what I like to do is I like to put a little arrow or a dot next to the ones that we're trying to prove that are congruent. So I don't want to make the marks already. Once those marks are all there, then I know I'm good. So they want us to prove 2 is congruent to 3. We want to get these 2 congruent to each other. Okay? So how do you think we're going to do that? Start with a given, absolutely. So in a paragraph proof, instead of 2 columns, we just say, we start with, like, conversationally. We are given that angle 1 is congruent to angle 4. That was our first sentence. Okay? Your attention getter. Your hook? I don't know. So since 1 is, or yes, if 1 is congruent to 4, you could start with that. Okay? Then, what else do we know? How are we going to get 2 introduced into this guy? Why does 2 equal 1? Awesome. So angle 2 is congruent to angle 1 because they're vertical angles. Okay. So then what I do is I go back over here and I make that arc. So I know I've got those 2 congruent to each other. So since now 1 is congruent to 4 and 2 is congruent to 1, what do we know? Doesn't 4 have to be congruent to 2? By what? They both equal 1, right? So should they be equal to each other? What would tell us that? What property can we use? by substitution. Okay, I like where we're going. Now we've got to get 3 in here somehow. What do you think, Zach? How can we introduce 3 into our proof? What does 3 have to be equal to? Why? Because it's vertical, absolutely. Angle 3 is congruent to angle 4 because they're vertical. Now we've got 4 congruent to 2 and 3 congruent to 4. Can we get to where we're trying to get? We're trying to prove 2 and 3 are congruent. They all have the arcs, right? So we have it. From these 2 statements, can we say then that 2 is congruent to 3? Absolutely. By what? Transitive? It could be transitive if we had written 3 congruent to 4, 4 congruent to 2, right? They'd be on the diagonal. But 4 congruent to 2, 2 congruent to 4, we're substituting, aren't we? We're taking out the 4 and placing it 3 and 2 congruent. That was a paragraph proof. Make sense? Okay. You could make this a 2-column proof instead, flowchart proof as well, but we wanted to just give you an example of paragraph. And if you prefer paragraph over 2-column, I will let you do it any day. Okay? All right. So these are key ideas from last chapter. Okay? If you're having trouble, struggling, it wouldn't be a bad idea to go back and get those. But this is what we're doing today since it took time to present. Worksheet today, and then we'll have a book assignment tomorrow.